I, Dr. Winkle Kumar Arora, will be presenting another aspect of the cold chain, that is the food freezing. This is the requirement where the frozen foods, products which are being in the frozen condition, that is below or at minus 18 degrees Celsius, that are to be handled. So this is nothing new which we are discussing, but since ages the human beings are preserving food by keeping it at lower temperature. So what is freezing? To lower the temperature of the food to a suitable degree where germs and bacteria are unable to thrive, thereby increasing the shelf life of the food. So this is basically the process of freezing. So freezings ensure the preservation of food in high quality, and at the same time this is ensuring that if the conditions are met during the storage, you will be getting the highest quality in the freezing process. So what does freezing do? So freezing is the use of storage temperature below minus 18 degrees Celsius to accomplish preservation, processing, and the some product categorization or the product requirements are meeting this particular food freezing aspect. For example, the pathogens growth it halted below minus 4 degrees Celsius. Spoilage microorganisms, they do not go at below minus 10 degrees Celsius. The chemical reaction rates, they are significantly reduced at lower temperatures. So all these aspects ensures the preservation of the food. Now, for example, some processing requirements are there. For example, if you want to slice a meat product, so the texture and desired viscosity, they are required for ensuring the processing. This can be achieved by freezing. So for certain products, for example ice cream, frozen desserts, they are categorized as frozen products. So there is a product requirement or product definition which requires freezing. Now basically what happens, the ice crystal formation happens inside the product. For example, the majority of the fruits and vegetables or the meat, they are having the higher water content. So this water is now converted into ice because of freezing. So less water is available for the spoilage. Because of this, the shelf life basically increases. Now if we see the different fruits, let us say apples. So if you want to have a short term storage, so you can have the temperature range from 1.7 to 4.4. For long term storage, maybe for more than 4 months, you can have minus 1.1 to 0 degrees Celsius. Okay, so now here this is the aspect which determines the storage life. At the same time, what is the relative humidity? For example, if it is a natural circulation, or we call it as gravity circulation, you will be having somewhat lower relative humidity. And for forced circulation, you can have the higher relative humidity of 88%. Now here one thing is very important, that with higher temperatures normally the humidity, relative humidity value decreases, and if that decreases, it will start taking the moisture from the product. So there will be a moisture loss during the storage, and therefore a good combination of relative humidity and temperature is must for the ensuring the quality and moisture loss is minimum. For example, here if we consider the freezing point, so this freezing point is minus 1.94. Normally we say water freeze at 0 degrees Celsius, but because of these solids the freezing point get depressed. So here this is minus 1.94, and here if we say water, it is having around 85% water. And what is the maximum storage period? You can store apples up to 8 months, but again that depends upon the ripening stage. Banana are the category where you have the a bit higher temperature ranges, again depend upon the ripening stage. For example, normally we keep from 12.8 to 13.3 for short term, and from 12.8 to 13.3 for long term. So there is no as such difference. So by gravity you can have 80%, and then the freezing point is minus 3.3 to minus 1.1. So having around 75% water, and you can store maximum period of 10 days. So here these are the few vegetables and fruits which I have listed over here for freezing. What are the devices available for freezing? So basically there are two categories of devices. One is the indirect freezers, and the second is called as the direct. In indirect freezer, there is a barrier between the cooling medium or the refrigerant and the food. So this can be either a plate or some environment, which is the mode by which the cooling effect is transferred to food. Second category is the direct. There is direct freezer, that is, there is no barrier to heat transfer between the refrigerant and the product. So let us discuss the first is the direct contact type freezer. Here we have a plate type freezer. So here the schematic shows that there are two plates which are carrying the refrigerant inside it, and then the food is placed in between this. So some pressure is applied so as to ensure maximum contact with the plates, and this will ensure the heat is given by the food to the refrigerant, and thereby it starts freezing. So normally this type of freezer is a vertical plate freezer, and this is a horizontal plate freezer, and there you apply the pneumatic pressure is applied to compressed air, wherein the maximum contact is ensured. So here the major problem is that first thing is that the food should be packed properly. If the shape is uneven, it is not possible to use the plate freezer, although we can use, but the efficiencies would be less. So for example, for a 1 to 1.5 inch thickness, so when it is cooled at minus 33 degree, it will have long freezing timings, 1 to 1.5 hours. So they are very slow freezing process, and then there are the repercussions for this slow freezing, so that we'll discuss in the coming slides. Next is the air blast freezer. So here this is a category wherein we place the product either in a batch or in a continuous fashion. So let us discuss the first schematic. So here these are the products which are placed inside the racks, and then there is the evaporator having the axial flow fans, and the air temperature is ranging from minus 18 to minus 34 depending upon the product, and the air velocity is as high as 4 meters per second. So this cold air is made to pass through this stacks, and then it takes away the heat from the product. Hot air goes back into the evaporator, gets cooled, and this is how the process is continuous. So this is a bit moderate freezing rate, and usually we have the air from minus 18 to minus 34 degrees Celsius, but this is a batch type of process. There is also a continuous type process wherein we are using the tunnel freezers. So you have a long slow moving mesh belt, and then this is made to pass through an enclosure, and then the air is made to pass through these fans. So this is a schematic of a tunnel freezer, so wherein the speed of the belt can be controlled, and this is the actual view of a batch type air blast freezer. Now what is the major issues or the challenges with this air blast freezing is that if you are having the product which is not packed, so there will be direct contact with the air, and there will be excessive dehydration because of the lower temperature of the air. Secondly, if the commodity is not properly clamped, it will be bulging out because of the higher airflow velocities. So the another concept is the fluidized bed dryer. So this is just a modification of the air blast freezers. So we call it as a direct contact type freezers, wherein the particle size in the range from 1 to 5 inches, they can be fluidized. Now what is the fluidized means? When the cold air is made to pass through over a continuously moving belt, some particles they fluidize and some particles they suspend in the air. Because of this suspension, there is a homogeneous cooling. At the same time, there will be no sticking of the commodity to the mesh belt, and at the same time there will be no solid loss. So product will be fed, and then it will be fluidized, and it will be quickly freezing. So this is a faster process because of these smaller dimensions of the product. For example, here if we see the product time required for reducing the temperature from from 21 degrees Celsius to minus 18 degrees Celsius. So peas will take around 3 to 4 minutes. Beans, they will take around 4 to 5 minutes. Diced carrot will be around 6 minutes, will be getting this temperature. Similarly, fish fillets, if you see, it will take around 30 minutes to get the temperature of minus 18. So here you can see the schematic wherein the products are fed inside a conveyor belt, which is meshed one, and then the air is circulated from the bottom. It fluidize or suspend the particles into the air, and then this cold air is sent back into the vaporite, and this is how the circulation continues. Another category of freezer, they are called as the spiral freezers. So it ensures that the compact environment for the freezing, wherein a very small space is required. So the products are taken on a spiral bed, and which is fed in a spiral fashion, and then the cold air is blown over the product with a very high velocity. So ultimately the product which is coming out over here. So this is the schematic of a spiral freezer. Normally for the raw or cooked meat patties, they are freeze during using this particular spiral freezer. Then you have the fish fillet, chicken, even your pizzas and chapatis or the parathas, they are freeze using this spiral freezer. Next is your liquid immersion freezers. Now this is a rapid freezing technology wherein the food products, they are either packed or unpacked, they are immersed in a freezant. Now this freezant can be propylene glycol, glycerol, sodium chloride, mixture of salt and sugar, depending upon the product type. So it is very important that if you are selecting a freezant which is toxic in nature, the food item should be properly packed to ensure there is no leaking of the freezant into the product and avoid direct contact. At the same time, it is very important to select the freezant very carefully depending upon the product type. Now for example, for canned citrus juice concentrate, for poultry, especially for fish and shrimps, we are using this liquid immersion freezers. Now it ensures very rapid freezing, but at the same time, to select a suitable freezant is a very big challenge in this kind of freezers. Next is the cryogenic freezers. Now this is a very rapid freezing. This is achieved by exposing the food directly to the very cold freezing. Now here normally we talk of a boiling nitrogen, which or the boiling carbon dioxide having a boiling point of minus 195 degrees Celsius. Now here this is an example where the product which is being freezed, it will be directly fed inside the liquid freezer tank, and then it will freeze very rapidly. Nowadays the continuous type this cryogenic freezers are also available in the market, wherein the liquid nitrogen is continuously sprinkled from the top on a conveyor line, and then this is a very rapid category of freezing. So these are the freezing method which have posed a solution to various of the problems which are encountered in the slow freezing process. Now let us discuss the quality loss at different freezing temperature. Now here, freezing is one way to quickly preserve the fruits and vegetables, but the degradation happen in quality when there are fluctuation in temperature. So once the product temperature is reduced, this ensures that the slowing down the quality deterioration process. It ensures there is no oxidation of the fat, the growth of microorganisms that is halted. At the same time, the enzymatic reactions and the loss of the surface moisture or the dehydration is accomplished because of the lower temperatures. Even the chemical changes which occurs once the fruit or vegetable is harvested, these chemical reactions or the spoilage enzymes, they also slow down because of the lower temperatures. So it means temperature is a very important aspect for freezing, and this ensures the quality during the freezing and during the storage. Now fresh fruits, fresh produce, they contain some chemical compounds, we call them enzymes. They are responsible for loss of color, loss of nutrients, flavor change, and even the loss of frozen fruits and vegetables, color changes. So these enzymes, they need to be inactivated. Now here let us discuss the first aspect for the pre-treatment before freezing is blanching. So this is a process which inactivates the enzymes in the vegetables. So what happens in blanching? Blanching is basically the exposure of vegetable to the boiling water or steam, and that is for a brief period of time. Then the vegetables must be rapidly cooled in ice water to prevent it from cooking. This is absolutely essential process for ensuring the quality of the frozen vegetables. So what happens in blanching? Blanching basically destroys the surface microorganism. At the same time, they make some vegetables compact, for example in spinach or broccoli. So blanching is a very important aspect. So let us see what blanching can do. So here this is the residual enzymatic activity of peas and green peas, and then their quality evaluation after 1 year in storage with different time for blanching treatment. So here hot water blanching is given at a 98 degrees Celsius, and these are the time combination. So when no blanching is given, when blanching is for 2.5 seconds, 5, 10, and likewise it is up to 3 minutes. And then there are three important enzymatic activity which are responsible for the spoilage, that is lipoxygenase, catalase and peroxide. So here if you see, as the time when there was no blanching, these enzymatic activity was occurring at 100%, and the peas were discolored, and then you were having strong off flavor. And even in the green peas, the discoloring strong off flavors and texture was retained when there was no blanching. But once the blanching is given, so here as the time increases, if you see at 20 seconds the activity has reduced to 0.2, and then there was no catalase and peroxide have drastically reduced. Then the aspect related to peas were not evaluated, but for green peas the color, flavor and texture were good. So for 3 minutes there was extremely low enzymatic activities. For peas the quality evaluation was good in terms of color and flavor. Similarly for green peas, this was have retaining color, flavor, and at the same time the texture was very soft. So here we have seen that because of the blanching, the residual enzymatic activity they slow down. At the same time the surface microorganism they get killed, and then even in the storage the color, flavor and texture can be good by this blanching treatment. Now let us discuss the problem associated with the fruits freezing. So basically in fruits there is a problem of browning, and then there is a loss of vitamin C. So this is the major challenge with fruits. So that's why we need to give some chemical treatment instead of blanching. So blanching is done only for the vegetables. So the most common treatment which is given for the fruits is the ascorbic acid treatment. So this can be used in the pure form or in the commercial mixtures with the sugars. Then there are some other solutions. For example, with vinegar also we can do some coating on the with sugar and lemon juice also. But these methods do not prevent the browning. So best method is to go with the ascorbic acid treatment. Now here this is the treatment method. You can crush 1500 mg of ascorbic acid, and then you can put it in a 1 cup of solution, and then dissolve this about half teaspoon of powdered ascorbic acid into each 1 cup of that. So you have to submerge the sliced fruits into the ascorbic acid for 3 to 5 minutes, and then you drain the ascorbic acid solution and place this into the freezer. For reuse also, you can also add some additional 750 mg of ascorbic acid for reuse of this solution. Now the another important aspect which is related to the food freezing is the rancid oxide flavors. So this is another group of chemical reaction that occurs in the frozen food products because of the contact of frozen food with the air. So this develops that rancid oxidative flavors. So we need to prevent the contact with air. So a suitable wrapping material which do not permit the air to pass through the product. These can be used for controlling this problem. And it is also advisable to remove the air which is there in the freezer bag before putting it in the freezer. Now another important aspect is the textural changes. As we all know that the water has a peculiarity that it expands on freezing. So if we go with the slow freezing rate, the size of the crystals would be larger. So here if we see, if we are going, this is an example where the freezing is done, let us say for 20 minutes. So there is a large size particle in small numbers which are observed in the frozen green peas. And if we go with quick freezing, small size particle in large number. And if we go with instant freezing or very rapid freezing, smaller particle size in very large number is observed. Now here what is the aspect of textural changes and how it is linked with the freezing dates? Slow freezing ensures the larger particle size, means the water which is there in the cells, it will be forming large ice crystals, and then these ice crystals will rupture the cell walls, and this will damage the texture of the product during the thawing. Secondly, with instant freezing or very rapid freezing, the size of the particle will be very small and they will not rupture the cell. So here the texture would be good after thawing process. So this is what I have already explained, that the cell wall rupture happen because of the slow freezing. So a difference in the texture is observed once the product is consumed or thawed. So that's why because of this, the frozen tomatoes, they are thawed and they becomes muddy and watery, and that's why we normally do not freeze tomatoes. So rate of freezing, this I have already explained that we need to go with the quick freezing methods, and usually we keep 2 to 3 pounds of vegetable each cubic foot of the freezer for 24 hours. Overloading of the freezer will result in the unfrozen products and ultimately the slow freezing, and ultimately you will be ending up with the poor product quality. So frozen esophagus example is also being shown over here. So slow freezing is not recommended. Now changes causes by fluctuation in temperature. Normally to maintain the top quality we need that the fruits and vegetables, they need to be stored at 0 degree Fahrenheit or lower, means minus 17.7, and there should be a separate freezer unit, and sometimes you have the freezer unit which are combined with the refrigerator unit. Okay, a freezer thermometer can help you to actually determine the temperature of the freezer. Storing food at a temperature higher than 0 degree Fahrenheit increases the rate at which the deteriorative reactions can take place, and it can shorten the shelf life of the food. So we have to ensure that the temperature do not increase during the storage. And secondly, the fluctuating temperature in the freezers can also cause the migration of water vapor from the product to the surface. Now this is again availability of the water for the deteriorative reaction. This will further lower down the quality, and then it will start the spoilage because of the availability of the water. Now this defects are normally observed in the frozen or the commercial foods, in which there is improper handling or accidental thawing or because of the power cuts. So these are the common issues which occurs during the temperature fluctuation. Moisture loss. Now basically the dehydration is another aspect which is very important and has an economic impact. Higher the moisture loss, the lower will be the price you will be getting for that. At the same time, because of the moisture loss, there will be frost accumulation on the coil surface, which will be reducing the heat transfer from the product to the evaporator coils. This will be a means direct as well as the indirect impact of the moisture loss. So how will you find out that there is a moisture loss? First is that there will be frost accumulation on the coils of the evaporator. So that is a gross indicator that there is the rate of dehydration or the moisture loss is higher. Now faster cooling can give the solution to this moisture loss. At the same time, combination of temperature and relative humidity can also ensure, and packaging and also help over a time depending upon the product. So for example, faster cooling and freezing greatly reduce the dehydration. There are two reasons for that. First, the temperature of the product which is reduced quickly, it minimizes the evaporation rate. So less water will be available for evaporation. Secondly, faster freezing minimizes the length of period which the evaporation occurs at the higher. So this means if you go with the faster freezing process, this moisture loss can be drastically reduced. Another aspect which we observe because of the moisture loss are the freeze burns. So basically it is the moisture loss or the ice crystal which are evaporating from the surface or the product, they form freeze burns. So they are basically the brown spots which are available where the tissues become dry and tough in the frozen storage. So if you see, these are the freeze burns which are observed in the plums during the storage. So it is highly recommended that freeze burn should not be there in the product because this will develop the off flavors over a period of time. So how to prevent these freeze burn? So packaging in a heavyweight moisture proof paper. So this can actually prevent the freeze burns. So if there is a layer of wax which is provided in a paper as a barrier, so this will prevent the moisture loss, and at the same time freeze burns can be eliminated. So there are certain microbes which grows in the freezer at lower temperature as well. So freezing is process actually do not kill microorganisms, but rather they inactivate them under the temperature. So when blanching is done, blanching although destroys some of the microorganisms, and then they decline the number of these microorganisms during the storage, but they do not ensure the quality enhancement during the freezing. So the products need to be carefully investigated if there is any accidental thawing which has happened. And in domestic freezers, you can obviously prevent the freeze burns. For example, here you can put inside a freezer paper, and then you can remove the air before putting inside the freezer, and then you have to label them when you are putting inside the freezer. So these are the aspects which are related to the freezing. But yes, there are different methods which are available for determining what is the freezing rate, what product will take how much time to freeze, and then careful inspection during the frozen storage is as important as the pre-treatment. So with this, I thank you all.